Hi, this is Mrs. Grosland. I am going to teach you Unit 6, Lesson 4. So disregard the one that says 6-1. It's 6-4. And our learning target is we're going to learn methods to determine if our answers are reasonable. All right, so here's our problem. How much change should be given if a $50 bill is used to pay for a $19.12 purchase? Okay, so remember our first step is what solution equation can we write? And you might think of this one of two ways. I think most kids would think of that as $50 minus $19.12 equals, I'm going to boost C for change. Okay, it doesn't really matter what letter I use there. Other people would think of it as the change plus the $19.12 would add up to 50. Okay, so that's our equation, and then you're going to solve your equation. So someplace on a piece of paper, in your notebook, solve that problem. So if you got $30.88, you did it correctly. All right, so next step, I guess this should have gone down there. Next step, how can I use rounding to see if my answer makes sense? Well, most of us would just leave the $50 alone. That's a nice even amount. And then the $19.12, most of us would round that to $20. Subtract, and you get $30. Our original answer was $30.88, so we're doing great. We're pretty close. Let's try a different kind of problem. How many school buses are needed to seat 351 students if 39 students can ride on each bus? Okay, so you're putting the kids into groups of 39. What kind of a solution equation can we write? Most of us would think of it as we're going to take those 351 kids and divide them into 39, groups of 39, and that's going to be our answer, the number of buses. Other people might think of it as the number of buses times 39 is equal to 351. Okay. All right, if you have a calculator, you could try to solve it on your calculator. If you don't have a calculator, do it longhand. Go ahead and try that. Stop the video and try dividing. Well, I love whoever made up this problem because it comes out exactly 9 buses. All right, it gets a little bit tricky when you're using rounding to see if your answer is correct. So I usually start with, well, you could do it one of two ways. You could start it with the number you're dividing by. So I'm going to round that 39 to 40. But if I round this first number, the number I'm dividing up, into 350, 40 is not going to go into it exactly. So I'm going to think about my multiples of 4 and think about how many 4s would come close to 35. Okay, so I'm thinking I could go a couple different ways. I could go 4 times 8 is 32. 4 times 9 is 36. 36 is a little bit closer. So I would do 360 divided by 40 is 9 exactly. Okay. Another way you could do it is round this number and then round this number to match it. But I think it's easiest if you start with the number you're dividing by and round it, and then they call these compatible numbers. Find a number that would go into exactly. All right, let's move on. All right, we're going to go into our textbook now. So if you don't have your textbook, just use a piece of paper and a pencil. It's Unit 6, Lesson 4. I believe it's page 265. And let's just try this number 1 problem, and then we'll drop down and try a different one. Number 1, altogether 91,292 people live in Waterloo and Muscatine, 2 cities in Iowa. The population of Waterloo is 68,406 people. What is the population of Muscatine? Okay, pause the video for a moment. See if you can come up with your equation and answer it. Did you get it right? 22,000 886 people. The estimate, usually we use front end rounding. You could probably round this to 91,000 if you wanted, or 90,000. I like to make it easy on myself, so I would just round it to the 90,000, and then again do the front end rounding here, and I would round that to 70,000. Probably not the most accurate rounding. More accurate would be to do 91,000 minus 68,000. But this one I can do in my head a lot easier, so choose something that's easy for you to do in your head. If you subtract, you get 20,000, and that is pretty close to 22,886. Here's a fun fact. Muscatine is known for its melons. It's muskmelons. Muscatine melons. All right, we're going to drop down to number 3, and I'd like you to try this one. In a school gymnasium, 588 students were seated for an assembly in 21 equal rows. What number of students were seated in each row? Write your equation and solve your answer. So for my equation, I did 588 divided by 21 equals R. You just as easily could have written R times 21 equals 588. If you solved it correctly, it came out exactly 28. I chose this problem because I think it's really tricky to estimate with dividing. Remember, we're going to start with our divisor. So I'm going to round that 21 to 20. And then I'm going to choose a number that 20 is going to go into evenly. So I'm going to kind of look at the 2's or look at 20. And I'm thinking 2 doesn't really go into 5. I'm not going to round that to 500. I'm going to round this up to 600 because I know 2 goes into 6. Okay? When you solve it, you get 30. 30 is close to 28. Now try number 4. To get ready for her first semester of school, Jana spent a total of $7.92 for 8 identical notebooks. What was the cost of each notebook? Write your equation and your answer, and this time I want you to try the estimate on your own. All right, here's one equation you could have written. I used N for notebook. Again, it doesn't really matter what letter you choose. You could have done C for cost. If you solved it correctly, you'd get 99 cents a piece. Now, depending on how you rounded, you might get some different answers. When it's a single digit like this, I would keep the 8 and 8. Okay, if it were 18 or 28, then I would round it to the nearest 10. But when it's a single digit, I just keep it as a single digit. And then what I would do is I would round this. Now I know 8's not going to go into 79, but I know close to 79 is 80. So I would change this to $8, and then I would get $1 here. Okay, now I know not everybody would solve it that way. You certainly could, So some of you may have rounded the 8 up to 10, and then you probably still would have chosen, I'm guessing maybe you chose $8, or maybe you rounded that up to $10 here. If you rounded it up to $10, you would get $1, same as we got before. If you changed this $7.92 to $8, then you would get 80 cents. Okay, and that's a little bit different than 99 cents. So can you see how keeping the 8 here would be really helpful? When it's one digit, just keep that digit. And now what you've all been waiting for is, what are we going to do about fractions? I know how you love fractions. Here's our problem. One box weighs 5/8 of a pound and another weighs 3/4 of a pound. What's the total weight of the boxes? Okay, pretty obvious. 3/4 plus 5/8 equals the weight. Okay, take a moment, get a piece of scratch paper. You can do it. Solve this problem. I'll give you a hint. Use 8 as your common denominator. Ready, go. Did you get 11/8? I'm hoping you didn't, because 11/8 is improper. Remember, when the numerator is bigger than the denominator, we divide it out. 8 would go into 11 one time, with 3/8 left. So the answer should be 1 3/8 pound. Now, what do we do if we're estimating? Well, usually what most people do is you either round to the nearest 0, 1/2, or 1/2. Okay, so I'm going to take that 3/4. Now, this is kind of a matter of opinion because 3/4 is halfway between 1/2 and 1/2. In this case, I would probably round it to 1/2. Okay, depending on what you're doing, you might want to round it down to 1/2. Okay, the 5/8, well, I know 4/8 is 1/2, and 5/8 is pretty close to 1/2, so I'm going to say 1/2. So you've got 1 and 1/2. Okay, 3/8 is pretty close to 1/2, so it's very close. All right, so if you run into problems with fractions, you're going to round the fraction part to either 0, 1/2, or 1/2. All right, I think we've got time for another problem in our textbook. So on page 266, we're going to drop down and do number 7. Okay, we've got to write an equation, and we're going to solve it, and then we're going to estimate it. I'm sorry, back up. We're going to do number 6. Okay, I wanted another one with fractions. So number 6, we're going to do the same thing. We're going to solve it, and then we're going to estimate. So we've got a cabinet maker cut 7/16 inch off of a board that was 2 7/8 inches long. What's the new length of the board? So if you're cutting something off, obviously you're taking away from that board, so it's subtracting. So 2 7/8 minus 7/16. Okay, take a moment, set it up off to the side. I'm going to line this up a little bit better. Find your common denominator and solve. All right. Did you get what I got? I subtracted wrong. Should be 2 7/16. Okay? All right. Now, how do you go about estimating? Well, look at the 2 7/8. Look at the fraction part of it. Remember, we're going to round it to 0, 1/2, or 1/2. I know that 1/2 is going to be 4/8, half of 8. And I know that 1/2 is 8/8. 7/8 is definitely closer to the 1/2. So this would be 1/2. I'm going to round that whole number up to 3. 7/16, well, 0/16 would be 0. 8/16 would be 1/2. 7/16 is pretty close to that 8/16. So I'm going to do minus 1/2. 3 minus 1/2, 2.5. Is that close? You bet. It sure is. All right. Try to use those strategies when you're solving word problems. It's always a good idea to check to see if your answer is reasonable by estimating. Remember, if you're doing a problem that you're going to be dividing, like 364 divided by 5, if it's a single digit, keep the 5 and find a number it would go into evenly. If it's a number like 364 divided by 27, round that. Round it to 30 and pick a number that 30 or 3 would go into. Fractions, you're going to round it to the 0, 1/2, or 1/2. Good luck!